Hello everyone, and thank you for joining my session. My name is Rajeev Chevuri. I'm a senior cloud and MLOps engineer with over 10 years of experience building large-scale cloud and machine learning systems. Currently at Freddie Mac, I'm a senior cloud developer on the enterprise data science platform. Today, I'm talking about scaling MLOps with self-service platforms. Here's a roadmap for my talk today. First, we will look at the evolution of ML operations, like how organizations moved from siloed experiments to enterprise-grade production systems. Second, I will introduce the self-service platform architecture and its key components, integration patterns, and the governance models that supports it. Third, we will discuss the measured impact and the implementation roadmap, including case studies, metrics, actionable steps for organizations that want to get started. And finally, I will share future trends and strategic positioning. Things like AutoML, serverless ML, and edge deployments, which will reshape how financial services approach MLOps in the coming years. So, by the end of the session, you should have a clear understanding of how self-service platforms can drive efficiency, governance, and innovation all at once. Let's begin with MLOps maturity shaped. In the financial industry, ML operations has gone through a big transformation. We started with siloed experiments. Teams build models in isolation, often without a path to production. Deployments are manual, slow, error-prone, and hard to reproduce. Environments are inconsistent. What worked on one laptop might fail in production. The governance was ad hoc, with little oversight of traceability. Overall, reproducibility was limited, making it hard to scale or meet regulatory requirements. Over time, this evolved into integrated platforms that standardize the full ML lifecycle. These platforms bring consistency, automation, and governance while assuring compliance. This shift from experimentation to integrated platforms is at heart of the scaling MLOps in banking and financial services. Now that we will see how ML operations was evolved, let's talk about why self-service platform matters. If you see, there is 71% reduction in the data propagation time because platforms provide standardized pipelines and reusable components. A 45% reduction in training cost by optimizing compute so the workloads run on their instead of wasting resources like GPU and CPU. A 38% improvement in deployment success with integrated CI/CD pipelines and consistent environments. But beyond the numbers, self-service platforms transform how financial institutions manage ML risk and compliance. They enable fast innovation while maintaining strict regulatory standards. Now, look at the core platform architecture. A strong architecture is the foundation for operational ML at scale. It ensures the platform is stable, secure, and compliant while supporting the ML lifecycle and meeting the regulatory needs. The architecture has three layers. The first one is foundation infrastructure. It scalable CPUs and GPUs, resilient storage, and secure networking. Organization must decide whether to go cloud or on-premises or hybrid. Here, Kubernetes play a key role in standardization, while strong data security is essential in regulated industries. The second one is data and feature management. A unified environment for data ingestion, processing, validation, versioning, and a central feature store. The feature store ensures consistency and while keeping everything auditable. The third, ML lifecycle management. This covers experimentation, training, versioning, deployment, and continuous monitoring. It includes CD pipelines, registries, testing, and observability, ensuring models are high performing and compliant. So, in short, infrastructure provides the power, data provides the foundation, and lifecycle ensures governance and control. Now, let's put the pieces together and work at the different architecture. In financial services, a platform like this is crucial. It abstracts infrastructure complexity so data scientists can focus on models instead of provisioning compute, networking, or storage. So at the same point, it's built for compliance. It ensures the strict controls, generates audit trials for lineage and deployment, and ensure separation of duties between developers, operators, and compliance teams. So when regulator asks how this model trained, who approved it, why data was used, when was it is it updated, the platform provides answers instantly. So in short, it streamlines operations while ensuring security and compliance. Now let's look deeper at the key components. Here there are four pillars. First, containerized orchestration. Kubernetes schedules ML workflows custom resources, define jobs, so they can run consistently across environments, ensuring scalability and isolation in multi-tenant setups. The second here is distributed compute. Spark and Dask handle large-scale data. They provide parallel computing and lineage tracking, so every transformation can be traced, which regulators demand. The third, the model registry and artifact stored. All trained models are versioned with compliance metadata, who trained them, when data was used, and when they were uploaded. So, upload workflows prevent unverified models from going live, and cryptographic checks ensure models are not tampered with. The fourth, CI/CD integration. Here, automated pipelines run test, security scans, and approval gates before deployment. This enables fast, consistent, and complete releases. Together, these four pillars make platforms scalable, secure, and auditable. Let's talk about governance layer. So up to this point, we talked about infrastructure, compute, and pipelines. The final layer that ties everything together is governance. So without governance, platforms in regulated industries simply cannot succeed. So it has three parts. The first, automated policy enforcement. The platform enforces access controls at runtime, respect model risk limits, and apply security consistently. Even if a data scientist misconfigures something, the platform prevents compliance issues. Second, compliance documentation. Model cards, lineage diagrams, and validation reports are generated automatically. Instead of manual documentation, evidence is corrected in real time as part of work. Third, observability. The platform captures logs, monitoring data, and explainability outputs. If a regulator asks, why did this model make a decision? The platform provides explainability immediately. The takeaway, the governments must be built in from the start, not bolted on later. Here, self-service experience developer view. The goal is freedom to innovate quickly, but within the compliance boundaries. This can be achieved in two ways. First, abstraction with control. Developers use curated environments with pre-approved packages, so they avoid setup delays, security risk. So templates given consistency across team for more flexibility. Code allows custom environments without breaking guardrails. Second, seamless workflow. With one click, developers deploy models into staging, compliance check, and documentation and automatically. Integrated debugging and monitoring help track performance, resolve issues quickly. For developers, the platform feeds simple and fast. Behind the scenes, it enforces governance, compliance, and security. Now talk about building versus buying. One of the most important questions here is, should we build the platform ourselves or buy a commercial solution? There are three options here. First, in-house development offers full customization and integration with legacy systems, but it usually takes months and requires a team of specialized engineers. Second, commercial platforms. Faster time to value, usually 3 to 6 months, and may include building complaints, but you may force vendor lock-in integration challenges. Third, the hybrid approach. Take a vendor core for speed, then add your own governance integration. These usually reach production in 6 to 9 months. For most financial organizations, the hybrid approach is the best balance of speed, customization, and compliance. Let's talk about future of MLOps. We will build strong foundations with self-help platforms, governance, automation, but the architectures of the future go further. It involves Edge ML, moves workloads closer to data sources. It reduces latency, improving privacy, and cutting cost. For fraud detection and trading, this makes a big difference. By ML, it enables automated model selection and tuning, with explainability built in so business users can build models safely. Serverless trainings, it shifts to event-driven, pay-per-use models, making processes simpler and cost-efficient, while keeping governance intact. Privacy-preserving ML, it uses federated learning and encryption to train across silos without exposing sensitive data. Today's architecture choices should prepare us for this edge native, automated, and privacy first future. Let's talk about edge native ML architecture. Traditionally, ML in finance has been cloud based, centralized training and inference. It works, but introduces latency and requires more sensitive data to the cloud. The next step is hybrid. Training in the cloud, inference at the edge. This reduces latency for real-time use cases while keeping scalability. The ultimate stage is edge native ML, training across distributed devices with the federated learning and running models directly on device. This cuts latency by up to 40% and enhances privacy since data never leaves its source. The future will be hybrid and edge native, combining cloud scale and edge responsiveness. Let's talk about emerging trends in financial MLOps. First, enterprise auto ML. Automation with guardrails, automatic model selection, hyperparameter tuning, but with explainability so regulators can audit outputs. Second, serverless training is an event-driven paper computation ML that eliminates heavy infrastructure while still enforcing governance. Third, privacy-preserving ML. It uses federated learning and encryption to train models without exposing sensitive data. This enables collaboration while maintaining privacy. Together, AutoML for speed, serverless for efficiency, privacy-preserving ML for compliance create the blueprint of next-generation MLOps. Here are the key takeaways. First, self-service platforms are so essential. Scaling ML financial services without them is not realistic. Second, governance must be inbuilt from the start, not added later. Third, start with the minimum viable platform, focus on the first friction areas, then expand. And fourth, plan for the edge native feature. Today's architecture decision will shape how ready we are edge, auto ML, and privacy preserving ML. Here's the 90-day roadmap. 1. Audit ML workflows and compliance gap. Define requirements with both technical and regulatory teams. Prototype quickly with a small team. It usually have 2 to 3 sprints. Deliver an MVP focus on high friction areas and measure success with KPIs like deployment time, governance efficiency, and developer satisfaction. So by following these steps, organization can move from experimentation to enterprise grade ML in a structured way. And that's it. I will bring this session to close. Thank you so much for your time.